Architecture shapes the climate crisis long before a building ever opens, and long after it should have been allowed to exist. I was taught, like most architects, to believe that better design, smarter technology, and incremental efficiency would eventually put architecture on the right side of history. The problem is that when you zoom out and look at the data, that story starts to fall apart. We're in the midst of a planetary crisis driven by human activity at a scale we've never seen before. Global temperatures are rising, ecological and social systems are destabilizing, and the effects are no longer abstract. Here's the uncomfortable question we rarely ask inside the profession. What if one of the largest drivers of climate change isn't cars, planes, or food systems, but the way we design, construct, operate, and replace buildings? Not as individual projects, but as a global system. A system that extracts enormous quantities of material, locks in emissions up front, and then routinely demolishes buildings long before their useful life is over. So the question becomes unavoidable. Is architecture killing the planet? I'm Darren, and this is Archi Next. Every few seconds, somewhere in the world, a new building is completed. Concrete is poured, steel fixed in place, glass installed. The system is designed to keep adding floor area. As the global population grows, so does demand for places to live, work, shop, eat and learn. Materials are extracted, buildings are assembled, waste is generated. Much of that waste is dispersed into land, air and water systems that have limited capacity to absorb it. By mid-century, the world is projected to add hundreds of billions of square meters of new building floor area. That is not incremental growth. It is a structural expansion of the built environment at a planetary scale. At the same time, climate risk is shortening the expected life of existing buildings. Flooding, heat stress, storms, and saltwater intrusion are making parts of the current building stock less viable faster than expected. So we are building more while losing more. That feedback loop matters. Architects like to talk about permanence. We point to historic buildings and say, look, architecture lasts. Sometimes it does, but modern buildings often don't. In 2021, a 12-story condominium building in Surfside, Florida collapsed, killing 98 people. It had been completed in 1981, 40 years old. Some of the contributing factors included long-term structural deterioration linked to saltwater intrusion. In other words, climate conditions interacting with materials and construction systems that were never designed to cope with them. The rubble was sent to landfill, the site was sold, and the system moved on. This is where the story becomes a feedback loop. Buildings contribute to climate change. Climate change accelerates building failure. Failure creates pressure to rebuild, and rebuilding locks in another round of emissions. The most sustainable building is often the one that doesn't get demolished. To understand why this matters, we need to be clear about two kinds of carbon emissions that both directly drive climate change and that are often blurred together in architectural conversations. The first is embodied carbon. These are the emissions released before a building ever opens. Material extraction, manufacturing, transportation, construction. Most of it is front-loaded, and once it's spent, it can't be recovered. The second is operational carbon. This is the energy used to heat, cool, light, and run buildings over time. Both end up in the same atmosphere. Climate physics does not care when emissions occur or whether they come from materials or operations. For decades, the profession has focused almost entirely on operational efficiency. Better installation, better systems, smarter controls. That work mattered, but it also created a blind spot. As buildings become more energy efficient and grids begin to decarbonize, operational emissions decline. Embodied emissions do not. In many high-performance buildings, embodied carbon can account for half or more of total life cycle emissions, which means early decisions about whether to build at all, how much to build, and what materials to use often matter more than the efficiency strategies we obsess over later. Here's where this becomes uncomfortable for architects. Good intentions are not the same as good outcomes. We celebrate new construction labeled as green, sustainable, or net zero, while really asking whether the building needed to exist in the first place. We treat certifications as proof of performance, even when measured emissions keep rising at the global scale. And we continue to equate architectural value with novelty, scale, and visibility rather than longevity and restraint. Measured honestly, it's not that architects don't care. It's that the system rewards the wrong things. So, is architecture killing the planet? If architecture is understood as a global system that continuously expands floor area, front loads emissions, and shortens building lifespans, then yes, it's a major driver of climate damage. But that same system also holds leverage. Buildings last decades. Decisions made early lock in consequences for generations. Reducing unnecessary construction, extending the life of what already exists, and treating material use as a finite resource all change the trajectory. The real question is not whether architecture can be part of the solution. It's whether the profession is willing to stop doing some of the things it currently celebrates. If you work in architecture, construction, or planning, ask yourself this as you watch. Which parts of this were never mentioned in your education or practice? Leave a comment. Disagreement is welcome. Avoiding the question is the problem.